Hello students, in today's lecture we'll see how we can use insertion sort algorithm to sort a given list of elements, and we'll also go through its time complexities.
So today we'll look at the next sorting algorithm, which is insertion sort. See, let's understand the basic idea behind this sorting algorithm. The basic idea says that we need to pick up one element from the unsorted list and find its correct position within the sorted list and place it. Okay. So now let's try to implement this using the given example. I have already taken the example of an array A of size 6 and I want to sort it in ascending order. Okay. So let's see what the steps of the algorithm are. So in this particular algorithm, we assume that the array is divided into two portions. The first part represents the sorted list and this second part represents the unsorted list. Okay. So now just try to recall the main idea that I told you, that we have to pick one element at a time. So we are going to pick up the elements one by one and we are going to find its correct position in the sorted place. We are going to find its correct position within the sorted place, which is this. Correct. So we are going to find its correct position within the sorted list and insert it. Okay. So let's see how we are going to perform this. So firstly, I am picking up the element 8 from the sorted list. This is the first element. So now for the coding purpose, we have to make I equals to 1 and j equals to 0. So if I put I equals to 1 and j equals to 0, that means I is pointing to this particular element and this element is pointed by j. Okay. So now we are going to check the correct value of this particular element into the sorted place. So we compare 8 with 15. We perform a comparison here and we see that 8 is smaller than 15. As soon as we find out that 8 is smaller than 15, what we should do? We should place it before it. So to establish this particular function, we will take another variable called temp. You can keep any name of this variable. I am keeping it to be temp. So this, I'll put the value of the element that I am picking up from the sorted list and I am going to put it into the variable temp. So now when you check 8 and 15, you find that 8 is less than 15. So we shift the value of 15 by 1 to the right. Okay. So we are going to shift the value of 18 by 1 to the right. So if j was pointing to 15, now what I'll do, since 8 is less than 15, what I must do? A of j plus 1 equals to A of j. So what is my j here? It's 0. This is A of 1 and this is A of 0 here. Okay. So I am putting the value 15 into A of 1 and after 15, since there is no element, so I can directly apply insert 8 into the column, 8 into the cell preceding the value 15. So A of j equals to temp. That means A of 0 equals to 8. So now my array will look like this. So now my array has become like this. Understood? We have simply, what we have done here is, we have simply increased now the sorted lists size and decreased the unsorted list size, as we have picked up one element from the unsorted list and have inserted it to the correct position in the sorted list. Similarly, following this, we pick up the next element from the unsorted list. So we pick up 20 here and we put it into the value temp. We have temp equal to A of I. So now you must have also increased I here. This was the previous I. Now you have also increased the value of I. So I plus plus is also done here. So temp is equal to 20. Now we check whether temp is less than A of 1. See, now the checking will be done from right to left when we are checking from within the sorted list. So you check if temp is less than A of 1, then A of 1, yes, A of 1, then shift A of 1's value. Then shift the value of A of 1. That means 15 will be shifted here if temp would have been less than A of 1. But since it is not less than that, therefore this shifting does not take place. Since 20 is greater than 15, so simply we can say that in the next step, we have increased the size of the sorted list, but no shifting or swapping or placement of elements had to be done. So now this is my sorted area and this is my unsorted list area. Now I pick up the next element, which is 1 here. As soon as I pick up 1, what happens? I first put it into the value temp. So temp's value is 1 currently. So now I basically compare first 1 with 20. 1 is less than 20. So what we'll do, if I make the array, which we are going to find out after performing this, then what will happen here? I'm just writing it down. Give me a minute. Okay. So basically now what I'll do is I'll compare 1 with 20. So I'll compare temp with 20. Since the value of temp is less than 20, therefore we are going to shift the place of 20. So now 20 is here. Next I am going to compare temp with 15. Value of temp is 1. 1 is still less than 15. So we are going to shift the value of 15. Then again we are going to compare 1 with 8. 1 is less than 8, but we have reached index 0. So we'll simply shift 8 and insert 1 here. So now this part is my sorted list and this is the unsorted list. Correct? In the next iteration, what is the value of temp? We pick up the next element, which is 18 here. Okay, let me draw the array for you. Okay, now I have picked up 18. First I'll check temp is less than 18, sorry, temp is less than 20. I check with the first element from the sorted list, first from the right. So I check, yes, temp is less than 20. As soon as I find this, what I'll do, I'll shift the position of 20. Okay, I'll shift the position of 20 and then I'll go for further checking. Then I check whether 18 is less than 15. No, this is not the condition. So what I'll do, I will insert my temp value here and then I'll stop any more comparisons. Correct? Now after this iteration, this is my sorted part and this is my unsorted part. Now again I pick up the element from unsorted list, put it into temp so that I can find its most appropriate place. Correct? Then I will compare it with the first element from the right from the sorted portion. So I am going to compare 2 and 20. Since 2 is less than 20, therefore we shift 20. Then we will compare it with the next element. 2 is still less than 18, so we shift the position of 18. Then we compare 2 with the next element, which is 15. Again 2 is less than 15, so we will shift 15. Then we perform a comparison between 2 and the next element, which is 8. Again 2 is less than 8, so we shift 8. Then we perform the comparison between 2 and 1. So here we find that the value of temp is greater than the element which we have picked up from the sorted list. So we'll insert 2 here. Instead of shifting, we'll insert 2 here and keep the position of 1 unchanged. So this is the final array that we'll get after performing insertion sort. Now let's look at its time complexity. If we talk about the time complexity here, what will happen? What is the best case that you will find in this case? The best case will be an already sorted array. Say you have an array like this. You have seen this example in the previous sorting also. Say we have an array like this. So in the first step, this is your sorted part, this is your unsorted part. So what will happen now? We are going to compare first this element with this and we are going to insert it to the right. So basically what will happen? This particular thing will come here. Now this whole has become the sorted array. Then simply this comes here. This whole part will become your sorted array. And once we have done it for one whole time, we can stop here. Why? Because this is an already sorted array and no swapping or placement of the things are taking place. So we can say that the best case time complexity will be big O of n. See, the swapping loop you are saving. Basically you are saving the swapping loop. You need not check it. You are checking it with the first element. Say when you are talking about 20. You checked it with 10 and that's it. You are placing it. Because 10 is less than 20. If you say, now let's consider that we have reached till here. Okay. Now you pick up 50. You only have to compare it with 40 and place it. So basically you are saving the inner loop where you are doing the comparison to place it at the correct position. You only have to consider the loop, the loop which you are using for considering every element of the given list. So in best case, when the array is already sorted, our time complexity will be big O of n. And as you could have already guessed till now. I think you must have already guessed it, that in worst case both the loops will run for every element, which will be the case when the array is sorted in reverse order. Array is sorted in reverse order. For that, since both the loop will run to its full capacity, we'll get a time complexity of big O of n square. I hope this algorithm is also clear to you guys. Okay, thank you.